Right, in this video, we're going to do some problem solving on trigonometry using the followings. We have learned how to apply the Pythagorean identities, the ratio identities, and the reciprocal identities. So the questions that we are going to solve later on will involve these three different concepts. All right, the first questions we're going to solve is to simplify this expression. If you are given cos theta times tangent theta, how can you simplify it? Right, so let's write down all the formulas we have learned earlier on. Okay, we have learned how to express tangent theta as sine theta over cos theta. We have learned that secant theta can be expressed as 1 over cos theta. Cosecant theta is 1 over sine theta. Cotangent theta is cos theta over sine theta. Then, of course, the Pythagorean identities. Sine squared theta plus cos squared theta equals to 1. 1 plus tangent squared theta equals to secant squared theta. 1 plus cotangent squared theta equals to cosecant squared theta. It would be good that if you can memorize all these formulas. The Pythagorean identities will be given to you in the formula sheet. However, the reciprocal ratios and the tangent theta equals sine theta over cos theta, cotangent theta equals to cos theta over sine theta will be given to you in the formula sheet. Right, so which formula can we use to simplify the expression given? Yes, cos theta tangent theta means cos theta times tangent theta, and we can actually apply tangent theta equals to sine theta over cos theta. We can apply the concept there. That means we can actually replace tangent theta with sine theta over cos theta. Alright, and then you just multiply the numerator and multiply the denominator to gives you cos theta times sine theta over cos theta. And cos theta divided by cos theta gives you 1. So 1 times sine theta equals to sine theta. So this is how you can actually make use of the formula on the right to simplify the expression. Alright, let's try the second one. Let's write down all the formulas first. Possible formula, the ratio identities, reciprocal identities, and the Pythagorean identities. So which one can we use? So obviously we will have to use the Pythagorean identities, because if you see something like something squared minus something squared, then it's we should be using the Pythagorean identities. So which one should we use? Yes, we should use the one that I've indicated there, the one that boxed it up. Right, so secant squared theta can be replaced with 1 plus tangent squared theta. The very important thing is that you have to bracket it. Okay, why bracket it is important? Okay, that's what I've indicated here. You need to bracket it so that you can remember to change the sign. Plus times negative will gives you a negative here. And then when you simplify it further, you will get equals to negative 1. That's the answer. Right, let's do a slightly more challenging questions. But before that, again, let's write down all the formulas that we've learned. Your ratio identities, the reciprocal identities, and the Pythagorean identities. So which one should we use? Yes, we should use the reciprocal identities. Okay, so we're going to rewrite secant theta as 1 over cos theta. Alright, so what's the next step we can do? We can just multiply cosine theta at the numerator and cosine theta at the denominator. That means every term here, you multiply with cosine theta at the numerator. Let's see what you get. Yes, you will get 1 over cos theta times cos theta gives you 1. And then cos theta times cos theta gives you cos squared theta. Add the numerator. The denominator will just be sin theta times cos theta. Alright, then which formula should I use? Yes, we should be using the Pythagorean's identity. Right, so I can actually write 1. I can replace 1 as sin squared theta plus cos squared theta. Okay, so that will simplify to give us sin squared theta over sin theta times cos theta. Right, and then you can simplify further to be sin theta over cos theta, and that gives you the tangent theta. Right, so the moral of the story is that you have to write down all these possible formula, and from the formula you just try to link it. Look at the questions that you need to solve and link it to the possible formulas that you can use. Alright, now what we're going to do is we have to do some proving of identities. So when we have proving of identities, you usually have to prove from the left hand side to the right hand side, or from the right hand side to the left hand side. Right, but before that, again, let's write down all the possible formulas that we can apply. So all these formulas are like your tools, like the tricks in your bag. You must always have all these things, and then from there you look inside your bag and see which tools you can break it out. So we will prove from the left hand side, because the left hand side have more terms to work on. Yes, and we will replace tangent theta with sin theta over cos theta. Then change the division signs to multiplication, flip the sin theta over cos theta. Multiply numerator and multiply the denominator. Sin theta divided by sin theta gives you 1. And you end up getting cos theta, which is the right hand side. And that's how we prove the identity. Alright, let's look at another question. So again, write down the formula. So you realize that if you keep writing all these formulas 10 to 20 times, that it will stay inside your head. Alright, so which one should we use? Yes, we should use the reciprocal identity. Okay, and we will prove from the left hand side, because again the left hand side has more terms to work on. Right, so cos theta times 1 over cos theta will give you 1. At the numerator, denominator remains the same as tangent theta. Right, so what is 1 over tangent theta? So 1 over tangent theta is just, yes, the tangent theta, you can write it as sin theta over cos theta. So it's 1 divided by sin theta over cos theta. Then you change your division sign to the multiplication sign, and then you flip this guy. Right, you will have 1 times cos theta over sin theta, which is your cotangent theta. Alright, let's do a slightly more challenging questions. As usual, let's write down all the formulas, the possible formulas that we can use. Your ratio identity, reciprocal identity, and the Pythagorean identities. So which one should we use? We should start to prove from the left hand side. And of course, if we are talking about cosine squared theta, then of course you'll be using your Pythagorean identity. Alright, so from there we can actually make cosine squared theta the subject. Yeah, and then you substitute inside your cos squared theta. So we prove from the left hand side. Okay, it's a bit tricky here. Your 1 minus sin squared theta, you can actually, it's the same as 1 squared minus sin squared theta. So that will remind you of your a squared minus b squared. Okay, so you can factorize it into be a plus b times a minus b. So 1 squared minus sin squared theta will be factorized into 1 plus sin theta times 1 minus sin theta. Okay, and then 1 plus sin theta here with your 1 plus sin theta at the denominator will gives you 1. Then you simplify further, this is what you get. Okay, right. Beware of this, the negative times negative will give you a positive. Right, and this is how you end up with sine theta, which is equals to the right hand side, which is equals to that we have managed to prove the identity. All right, let's do another example. So as usual, let's write down all the formulas. Yes, we'll prove from the left hand side first, but let's write down all the formulas. So you realize that for the past few examples that we've been doing, past few questions we've been doing, we always write down the possible formulas that you can use. Okay, let's start with the left hand side. So which formulas can we use? Yeah, tangent theta, we can actually write tangent theta as sine theta over cos theta, and then the cotangent theta will be your cos theta over sine theta. So can you see the techniques that we're using here? It's write down all the possible formula and then look at the questions and we try to do a matched. Like look at the formula, see which one we can use to match it with the questions. Right, so now we have two fractions. So how do you manage two fractions? Yes, we find your common denominator, which is sine theta times cos theta. Right, so the first fractions, you just multiply by sine theta at the numerator, also at the denominator. So you end up getting sine theta times sine theta. Then the second fractions, you multiply with cos theta at the numerator and denominator. Then you end up getting cos theta times cos theta. Right. So what is sine theta times sine theta? Yes, that gives you sine squared theta. And what is cos theta times cos theta? That gives you cos squared theta. And what is sine squared theta plus cos squared theta? Yes, that is our Pythagorean identity. That is equals to 1. Okay, so we have 1 over sine theta times cos theta. We can break it up into 1 over sine theta times 1 over cos theta. And then what is 1 over sine theta? 1 over sine theta is this guy here. Which is your cosecant theta. And 1 over cos theta is this guy here, which is your secant theta. Okay, and then you rearrange it. That means because you're asked to prove it to be secant theta times cosecant theta, so you just rearrange the sequence. So you write secant theta first, followed by cosecant theta. Then equals to right hand side equals to proved. All right, let's do another question. In this case here, before we start proving it, let's write down all the formulas again. Okay, so the formulas are all our tricks. All right, we must always have them in our bag. Okay, so then you will know which one to take it out. Okay, we start proving with the left hand side. Yes, we're going to replace 1 with sine squared x plus cos squared x. Why is that so? Because the sine squared x plus cos squared minus 2 cos squared x will simplify into sine squared x minus cos squared x over sine x times cos x. Here, some of you may be tempted to use a squared minus b squared, right? Because sine squared x minus cos squared x can be simplified, can be factorized it to be sine x plus cos x times sine x minus cos x. But we're not going to do that. Okay, why we're not going to do that? Because if you were to look at what you need to prove, okay, what you're going to need to prove is two fractions. Okay, so what we are having right now is one fraction, so we have to break it up into two fractions. So how do we break it up? Yes, this is how we break it up. Okay, then from there you can simplify further to get sine x over cos x, then minus cos x over sine x. Then sine x over cos x is your ratio identity, which is your tangent x. And cos x over sine x is your cotangent x, which is what you need to prove. Okay, so in case that if you did not break it up into two fractions and you use what I've mentioned earlier on, you're going to factorize it. If you don't get the answer, don't worry. All right, so you will just try again. That means if this method doesn't work for you, then try again and try a second method. All right, you just have to keep trying until finally you manage to get the answer. And after trying so many times, you would have gained enough experience to know which approach to take. So the important thing is that do not afraid to try and try and try, and finally gain enough experience to know which approach to take. Okay, so these questions that we're dealing with, it's different from what we have done earlier. This questions is it's more challenging in the sense that you will have to do some simplification first. In this case here, we have to apply this cross multiply concept here, right, to simplify the equations given. So when you do a cross multiply, this is what you get. Okay, you take 4 multiply with sine theta plus cos theta. Make sure you bracket your sine theta and cos theta, and then you cross the other side. And then don't forget your equal sign. You need your equal sign in the middle. Okay, and then you open up the expand. There's 2 brackets there, you expand it. Right, then you group all your cos theta together, and then you group all your cos theta on the left, the sine theta on the right. Okay, then what's the next step we do? Yes, we can divide both sides by cos theta. Why do you want to do that? Because sine theta over cos theta, what does it give you? Yes, it will give you tangent theta. So tangent theta equals to 9. And so if tangent theta equals to 9, then tangent squared theta will be just tangent theta times tangent theta, right? Tangent squared theta is tangent theta times tangent theta. So that gives you 9 times 9 gives you 81. And once you know that, you can just plug into your expression and you'll get 41 over 40. Okay, right. So it's slightly different from what we have done, but the concept is still the same. What do you mean by the concept is still the same? It means you still have to apply your ratio identity. You still need to apply this guy here. Sine theta over cos theta gives you tangent theta. This is what I mean that um, the structure of the questions may be different, but the underlying concepts is the same. We still have to apply the trigo formulas that we have learned earlier. Okay, so this one we recall your Pythagorean identity. Sine squared theta plus cos squared theta equals to 1. Right, so hence we can write, so that means if you have 2, if you have this number 2, we can actually write 2 as 2 sine squared theta plus 2 cos squared theta. If you have this number 3, you can actually write 3 as 3 sine squared theta plus 3 cos squared theta. Because sine squared theta plus cos squared theta equals to 1, right? So why do we want to do that? Because if you look at 9 part 1, this is what exactly we're going to do. We're going to replace this guy here with this. Right, so that I can simplify further to get this. Cos your 2 squared theta minus cos squared theta, this one here, will give you cos squared theta. And then what I've done is that I bring this term to the left hand side. And then what do I end up with? I actually end up with a quadratic equations. So what do you do with the quadratic equations? Yes, you factorize it. Okay, you factorize it using the cross method. Here you can't use your calculator because you're dealing with variables. Alright, so you have to use the cross method to factorize it. So 2 sine theta times sine theta will give you 2 sine squared theta. Then negative cos theta times negative cos theta will give you cos squared theta. And then if you do a cross multiply, you will get this term, sine theta times negative cos theta. And then the other one, you get this. Okay, so this is how you factorize it. If I'm not too sure, you have to do a revisions on the cross method again. Alright, so this is what we get in the end. Then you apply the zero product rule. So we can have 2 sine theta minus cos theta equals to 0, or sine theta equals to cos theta. And then here we're going to apply the ratio identity. divide, yes, both sides by 2 cos theta, you end up getting tangent theta equals to half. The other one also divide both sides by cos theta, that will give you tangent theta equals to 1. So the two possible values of tangent theta will be half or 1. Right, so for part 2, what happened? Alright, for part 2, if you're told that sine theta is not equals to cos theta, then will you still get two possible values of tangent theta? This is what the question is asking you. Right, if sine theta is not equals to cos theta, will you still be having tangent theta equals to half and tangent theta equals to 1? Yes, of course you won't. Because to get tangent theta equals to 1, right, we need sine theta equals to cos theta. It's from sine theta equals to cos theta, then you get tangent theta equals to 1, right? So if you are told that sine theta is not equals to cos theta, then this one is not valid. It does not exist at all. If it does not exist, then what happened? We will only be left with one answer, and that is tangent theta equals to half. Okay, so that's the end of the whole video on problem solving using ratio identity, reciprocal identity, and the Pythagorean identity.